As we start to look at the shift from the classical clinical device setting to more of a home care setting, I think we've noted that there have been significant challenges that exist in the realm of how do we look at the life cycle of the device, how do we handle cleaning and disinfection. What suggestions would you have for manufacturers who are just starting to go down the pathway of biocompatibility testing?
Yeah, that's a great question, and we're seeing more and more feedback from international and national regulatory agencies about ensuring that the life cycle of the device is accounted for. So we know that's a big clause in 1093-1, and we know that historically medical device manufacturers don't always think about that up front because of course they're worried about just getting the device tested normally. What we know to be true, however, is that a lot of the ways medical devices are cleaned, disinfected, or sterilized can actually affect the polymers. They can affect the polymers, they can affect how the surface interactions occur, and that can sometimes, depending on the type of contact that the device makes, that can change the leachables profile or potentially change the biological risk that's present. So now we're advising clients to start thinking about that up front prior to them starting a biocompatibility program. And in certain cases, we're recommending additional sets of testing, but in other cases, we're developing some modeling that we can talk about a little bit.
So from the perspective of cleaning and disinfection, if we think about the instructions for use for a device, the concept of having 5 different ways or 10 different ways to potentially clean it, that is going to provide some more challenges to customers because at the end of the day, we have to take into account the worst case scenario for the device. How do we begin to approach that from that perspective?
That's also a great question. So I think lately what we've been advising clients is first starting with the IFU, making sure that we understand what chemicals are being used. And then talking a little bit about what we know to be true in just generic polymer behavior when polymers are exposed to some of these chemicals, and doing some sort of modeling and simulation, some literature reviews, talking a little bit high level about mechanical and material properties to account for that. And then talking about how the device is used, what its normal environment is that it's exposed to, and how that might change if it goes through, let's say, 50 life cycles of isopropanol on the outside. And in some cases, doing a select set of 1093 testing or a chemical characterization program may be sufficient. In other cases, it might just be a literature review and a talk of polymer behavior. It really just depends.
And that's really been where we've recommended that instead of a singular approach to this, it's more of looking at the tools that we have from a failure analysis or a failure modes and effects analysis in order to properly select what conditions are truly worst case. So use the concept of the risk-based approach to medical devices to truly define what the risk is for the device. Therefore, when we want to characterize a hazard, we know where to begin and we can rank the risks to allow for us to properly select what that end of life cycle looks like for a device. And I think it's also an interesting piece for the device manufacturers because at the end of the day, they should also consider that having 5 or 10 or 15 different cleaning processes or sterilization processes, while on the surface it may look like a really good marketing tool, it may provide a lot of cost on the back end because just looking at some of the basic programs, you could be in the multiple millions of dollars in order to characterize the end of life of a device.
Absolutely.